system receives air from three main sources: the engines, the APU, and ground pneumatic sources. Bleed air from the engines, APU, and ground sources is supplied to using systems through bleed air ducts. The following components and systems use bleed air: air-driven hydraulic pumps, wing anti-ice, cargo heating, engine and APU starting, air conditioning packs, potable water pressurization, hydraulic reservoir pressurization, and trim air. Controls for the bleed air system are located on the overhead panel. These switches control bleed air isolation. These switches control engine bleed air, and this switch controls APU bleed air. Let's discuss the APU bleed air system in more detail. Bleed air from the APU is used primarily on the ground for air conditioning, and engine starting. However, bleed air from the APU may also be used in flight up to an altitude of approximately 22,000 feet. Let's use the air synoptic to see how the system works. Display the air synoptic. The APU bleed air switch is normally left in the auto position for automatic operation. Select the APU bleed air switch to auto. Positioning the APU bleed air switch to auto with the APU running causes the off light to extinguish. It also opens the APU bleed air valve and all three isolation valves, allowing air into the bleed air ducting. Duct pressure indicators on the synoptic indicate pressure in the ducts. Bleed air is now available for the air conditioning packs and for starting the left and right engines. Let's discuss engine bleed air operation. Bleed air from the engine comes from the low pressure or LP section. Air from this section is used primarily during high thrust settings such as takeoff, climb, and cruise. Bleed air also comes from the high pressure or HP section. Air from this section is used to supplement low pressure air during low thrust settings such as during descents. The engine bleed air system is controlled by the Air Supply and Cabin Pressure Controller, or ASCPC. The ASCPC opens and closes the high pressure or HP valve. It modulates the pressure regulating and shutoff control valve, or PRSOV. And it limits bleed air temperature in the ducts by modulating the PRSOV. Watch what happens as the system responds to an increase in bleed air temperature. Normally, the engine bleed air switches are left in the on position. Push the left and right engine bleed air switches to on. Notice that the off lights remain illuminated. The engine bleed valves, as shown on the synoptic, remain closed because there is no bleed air from the engines. Now watch the engine bleed air indications as the left engine is started. Start the left engine. Notice that the left engine start valve is now open. It opened when you positioned the start switch to start. During engine start, bleed air to using systems, such as PACS, is automatically shut off. When bleed air is available from the engine bleed valve opens. As the bleed valve opens, the off light extinguishes. In this condition, bleed air from the left engine supplies the using systems. If the other engine is not started within a short time, the PACS resume normal operation automatically. When an engine is supplying bleed air, the APU bleed air valve closes. The APU bleed air off light remains extinguished when the APU bleed switch is in auto and the bleed valve is performing its normal automatic operation. Now touch the green arrow to watch as the right engine is started for you. Even though the left engine is running, bleed air from the APU is normally used to start both engines. Selecting Start for the right engine opens the start valve. Again, bleed air to using systems is shut off. Once bleed air is available from the right engine, the engine bleed valve opens. As the bleed valve opens, the off light extinguishes. Now, both engines are supplying bleed air to the various using systems. These switches control bleed air isolation and are normally left in auto. Select Auto on the left, center, and right bleed isolation switches. With the bleed isolation switches in auto, the closed lights remain extinguished when the isolation valves are performing their normal automatic operation. During normal operation, the bleed isolation switches send an enabling signal to the ASCPC. The ASCPC controls the position of the bleed isolation valves. Next, take a look at several situations where the bleed isolation valves are controlled automatically. When a ground air cart is supplying bleed air, the left, center, and right isolation valves are open. If the APU is supplying bleed air with the engines off, all three isolation valves are open. During left engine start, the right isolation valve closes and the left and center isolation valves open. During right engine start, the left isolation valve closes and the center and right isolation valves open. During a cross-bleed start, the ASCPC automatically opens all three isolation valves. And finally, during engine-out operations, all isolation valves are open. Let's look at non-normal operations. We begin with bleed leak detection and automatic isolation. The bleed leak detection system protects bleed air ducts throughout the airplane. The areas protected include the engine struts, the left wing area, the right wing area, and the body duct. Here's an example of how the system works. A leak is detected in a duct. After a short period of time, the system closes bleed valves and isolates the duct. Following the isolation, a bleed loss message is displayed on ICAS indicating which area has been isolated. This system is automatic and crew action is not required to detect and isolate the leak. Now here's an example of a duct leak, isolation, and resulting losses. Assume there is a leak in the body area. The caution message, "Bleed Leak Left," is displayed on ICAS. The system begins an isolation routine and for a few minutes manipulates valves as it isolates the leak. After the system isolates the duct and the leak is no longer detected, the ICAS advisory message, "Bleed Loss Body Left," replaces "Bleed Leak Left" on ICAS. Notice that the isolation routine has shut off the air supply to several systems, including the hydraulic C1 demand pump and the aft and bulk cargo heating. In this configuration, cross-bleed start capability and APU air are not available. Let's look at some of the other non-normals. We begin with the APU. If a system fault occurs, such as bleed air over temperature or over pressure, the first thing you see is the advisory message, "Bleed Off APU," displayed on ICAS. Simultaneously, the off light illuminates, and the APU bleed valve closes. Given this condition, bleed air from the APU is not available, and crew action is not required. The engine bleed air non-normal procedures are similar to the procedures for the APU. If a system fault occurs, such as bleed air over temperature or over pressure, the first thing you see is the advisory message, "Bleed Off Engine," displayed on ICAS. The off light illuminates, and the engine bleed valve closes. Again, crew action is not required. Isolation valves can fail either open or closed. Look what happens when an isolation valve fails open. First, an advisory message is displayed on ICAS. In this example, the message is "Bleed Isolation Open Center." As you can see on the synoptic, the center isolation valve remains open when it should be closed for normal operation. There is no loss of system functionality and crew action is not required. For our last non-normal, consider the following. Isolation valves can fail closed due to mechanical failure or due to a system fault. If a fault occurs, an ICAS advisory message alerts you to which valve has failed. In this example, the right isolation valve has failed closed. On the bleed air panel, the respective closed light illuminates. During normal operations, the left and right isolation valves are commanded open. In this example, the right isolation valve is not in its commanded open position. Also note that cross-bleed start is not available.